So here we are talking about group 7 elements in the periodic table. Keeping in mind what are they called? They are also called the halogens. They are also called what? The halogens, and they are the most reactive non-metals. Yes, group 1, the alkali metals, they are the most reactive metals, right? And they are the most reactive non-metals here we will be talking about. Then, as we go ahead, we will talk about their trends in their physical properties that will help us understand them better. So here, what do we say? Trends in their physical properties means we are going to talk about their physical properties. So here, when I'm talking about their physical properties, let me list them down first. What are they? Fluorine. Fluorine, its symbol is what? F, right? Then what do we have next is chlorine. Chlorine symbol is what? Chlorine is also CO. Then what do we have? Bromine. It is Br. Then we have iodine. Then what do we have? We have acetylene, and which is what? Which is AT, right here. So first of all, let's talk about their colors when we are talking about. So here, let me put it up. Here, what I will tell you about their colors. That as you know, we are going down. We will talk about it that color gets darker. What does it mean? When we say color gets darker as we are going down the group. Fluorine, which is actually pale green. Pale green. Then chlorine, which is actually what? Which is yellow green. Okay, so you see as we are going down, it is getting darker. Bromine is basically red brown. Then iodine, which is black or kind of dark purple. Acetylene also black. So as basically we are going down, it is what? It is getting darker and darker. Then, let's talk about another physical property, which is actually about their melting and boiling point. So that also, when we are talking about melting or boiling points, I write here, melting or boiling points increase down the group, as we can see. Then other than that, we will talk about their physical state at room temperature. Yep. Okay. So what will it be when we are talking about here, at room temperature? So when we are talking about at room temperature, this is basically, it will change from gas to solid as we are going down. What does it mean? Like fluorine, which is actually a gas. Fluorine is a gas. Then chlorine is a gas too. Bromine is what? Bromine is liquid. Okay, then you have iodine and acetylene, which is actually solid. So as we see, as we are going down, the state changes from gas to solid. So this is the main overview of the physical properties of group 7 elements, the halogens. So now about their physical properties, we will go to their chemical properties. Okay, what are these? So let's talk about trends in their reactivity. We are talking about halogens, right? The reactivity means we are talking about their chemical reactions, like how do they react. There are a few things that we will consider. What are they? Let's talk about it first. Group 7. As we know that group number, what does it indicate? It indicates valence electrons, right? So when I say group 7 elements, right? Group 7 elements, all of them will have what? All elements of group 7, all elements of group 7 have 7 valence electrons, right? 7 valence electrons. Valence means in their outermost shell. Then, other than that, what important point to be noted down? All halogens exist as what? Exist as diatomic molecule. What does it mean when I say diatomic? Di means two, right? In chemistry, what do we learn? Di means two. So when I say diatomic here, what I am referring to? I am referring to two. So F2, fluorine, chlorine, Cl2, Br2, bromine, I2, astatine, A-T2, right? So all of them, how do they exist? They exist as diatomic form. I make a bubble here. So this is very important thing that we will remember. It will help us, write equations properly with halogens. Now, coming back to more knowledge about it as we go down the group, reactivity decreases, unlike group 1. Group 1, what happens? Reactivity increases there, right? So here, as we go down the group, reactivity decreases. Means fluorine, it is the most reactive halogen, right? I write here. Okay, here, what do we have? This is most reactive halogen. Most reactive, and here you go to least reactive. As you are going down, reactivity basically what? Decreases. Then, we go next. What else we are talking about? Okay, more reactive halogen can displace less reactive halogen. What does it mean? We will understand it. Okay, also note that what to note, that less reactive halogen cannot displace more reactive. Less reactive halogen cannot displace more reactive halogen. What does it mean? Now let me show you with the help of example. So here in example, we will write word equation first. In word equation, what I am gonna give you, let's take here, what do we have? We have example. And here, what do we have? We have word equation. What is our word equation? Word equation, I'm gonna give you potassium. Let's take potassium bromide. Reacts with chlorine. And what does it form? It forms potassium chloride plus bromine. What did you observe? That bromine, it was less reactive than chlorine, right? So chlorine was able to displace it. Now let's write the chemical equation here. What is the chemical equation when I'm writing this? Chemical equation of it. Chemical, or I call it formula equation. Along the way, it's good to practice these equations too, because in chemistry, it is a very good practice to write proper equations. So what I'm gonna write here, I have potassium bromide KBr plus chlorine Cl2, keeping in mind diatomic. What will it form? Potassium chloride KCl plus Br2. To balance it, I would put 2 here and 2 here. This is going to be my equation for this. Okay, what explanation I may write? Yeah, that also I should practice so I become more, I'll have better understanding of the concept. What is that? Chlorine is more reactive than bromine, so it displaces bromine from potassium bromide, KBr. Right? So this should be the explanation that you should give, because every point we must be able to understand, like how we are going to explain it. We will be doing more examples to understand it. Okay, now we will write more examples of it where we will learn, like how more reactive or less reactive, how they can displace or cannot displace. So we will be doing 2 examples, example number 2 and example number 3. I am writing in advance, right? Okay, so in example number 2, what we will learn, like where we have just learned that more reactive halogen can displace less reactive ones. So here, what is that? I have given you the example of sodium chloride. Sodium chloride with fluorine. Sodium chloride with fluorine. So yes, what will be our products and what will be the equation? So this is the equation, NaCl plus F2, that will give us NaF plus Cl2. To balance this, we will write 2 here and 2 here. This will be our equation for this reaction where fluorine, it is doing what? Fluorine is displacing chlorine. And why is this so? This is because it is more reactive. We will write here, fluorine displaces chlorine from its compound. And why? Because it is more reactive than fluorine. Okay, yeah, so this is our full explanation that we need to explain. Now let's go to one more example where I give you lithium chloride plus bromine. Lithium chloride plus bromine. So here, what reaction, what products do you expect them to be? Yes, here we have this reaction where we are talking about lithium chloride reacts with bromine and no reaction occurs. And why is this so when we are saying? So yeah, we should be able to explain there will be No reaction. And why there will be no reaction? Because bromine is less reactive than chlorine, so it cannot displace it right now. So this is the thing that we need to remember about which one is more reactive and which one is less reactive, and keeping in mind only less reactive halogen can displace more reactive halogen can displace less reactive one, right? Less reactive halogen cannot displace more reactive. Yes.